In this session, I will give you an introduction to using children together with your particles. One common situation for it is when you are doing things like grass, vegetation on the ground, or where I have a lot of particles involved. So let's go right into the 3D viewport so you can see what we have here. And you can download a simple file, just called simple because the children's type is simple in this case, and then you would have what I have in front of me. I will use 4 objects here, so I have 1 type of flower and I think 3 types of grass. I also have 2 planes here, and one will be water and one is the ground, and the ground has the particles. Right now we don't have that many particles on here. If we look at the hair properties, you can see the hair type here, and we have only like 1,000 particles, and that means that it's easily to move around without lag or computer trouble. So this is a good amount of particles when working in the workbench. If I should do like 1 strand of grass as dense as it is in reality, it would be very, very, very hard for my computer to handle. And that is the reason that we use children. Many children can have the same parent. So what we see here, what we show, are the parents. Our children's in this session will be of type simple, and that means that all the children starts at exactly the same spot as the parent. They also use exactly the same physics as the parent. And of course, then we can tweak it a bit by moving the children around to scatter everything, but they still uses the same physics as the parent. And this means that the computer only have to calculate the parent. Okay, so the children is then placed exactly as you have the parent. So that is why you use children. It will be a lot easier for your computer to work and a lot easier for you to work without lag. So what have I done here? We have, like I said, put our objects here. I have like 1,000 of them, just jitter them around. I have selected them as a collection, and I call that collection stems, where I have everything. And then we have this part here at the bottom called children, and all we have to do is press simple. And when we press simple, you get all children in place. If you don't want to see the parent, then you just uncheck parent particles to not see it. So here you have parent particles checked, and now you see them. And if I go back and uncheck, you can see that we get a few of them. It could be so that you don't want to see the parent, because after you have tweaked the children, they can be small or big or look quite different from the parent. And in that case, the parents are so obvious, so it really does disturb the picture. In that case, you will just remove it. This time I'll keep them, so you can compare the difference between the children and the parent. Then we have the display amount and the render amount, and that is also to avoid heavy load on the machine. So lower value in display amount makes it easier to work. Okay? So normally you put the display amount lower than the render amount. So if I take this up now, you will get a lot more grass, and you can see that my computer works much harder to put everything in place. It's a lot of lag here. I can hardly move anything because I try to show thousands of children and it will not work. That is why we have the possibility to decrease the amount of what we should display here. So if I just write like 10 here, if I don't get choked by my computer. I'm now back and everything is smooth again to work with. Now you know why we have the display mode. Okay? The render amount is actual amount when render. And then we have the length of the particles. So if I have 1, then we have the same length as the parent. We can decrease it a bit if we want to. If we want to decrease it at all, if we don't want to decrease all of these particles, you can use the threshold. The threshold decides or filter out some of the particles so they have the same size as before or are unaffected of the length. So you can see the difference between 1 compared to like 0 here. So if I put it to 0, all of these are affected when the length is coming into the picture, but with the threshold of 1, none of those change, even if I change the length here. So if you put that to a rather low number, you get some random things in here. Okay? Then you have the size. Size is almost like length, or like it's a percentage of the length. So now it's 100% of the length, but then I can increase or decrease it. With the size, you can decide, so we can get some random in the length here. So when I change the random size, we can get some that is a little bit shorter and some that are a little bit longer. So with the size here, you can decide how scattered you want the length to be. And after that, we have what is called the radius. Here, the type is simple and interpolated, and that is a different thing when it comes to simple. All the children grow on the same spot as the parent, and I told you that. But you can scatter them out by using this radius. If I just put it out a bit, you can see that they are more spread from the base now. And if I take it even more, you can see it gets more and more spread. And I can take that number really, really high up. So right now it's okay. But if I take it really high now, you can't control where is the parent, what combines the parent and the child. Everything is so scattered. So that is a very easy thing or easy way to scatter everything away. Disadvantage is that the scatter can get outside of this plane, and it's up to you if you want that near your parent or not. But that is how you can use the radius here. Then you have the roundness, and roundness is how they create like a sphere or circle around the parent. So if you have a lot of roundness, they will circle like a UV sphere around your parent. And that means that they will also go up and down a bit here. If I now increase the roundness and you go a bit closer here, you can see that we have some objects that go under and some that goes up. So be a bit careful when you're working with roundness here, because it will also work in the like Z axis. And then we have the thing called clumping. And clump, that is how to bend compared to the parent. So if I have a clump of a negative value, the children would start near the parent. If you look at the root here, it would then be very, very close to the parent. So that is how that works. But if I change it to positive clump instead, the bending will be at the top. So you get a lot of scatter near the roots. You can control everything more here with the shape as well. Radius and clamp works good in combination, and here's an example. So say that I put everything together using the clamp. So I use -1, then everything is together here. If I then increase the radius, you scatter everything at the top while maintaining the root position. So it will be like this. So it's one example where I can use the radius together with the clamp, and you have to experiment a bit to find what works to you and to this particular scene here. But now you know how you can combine everything there. Okay, let's look a little bit more on shape now. So if you look at shape, this is connected to clump, and shape decides where a straw should be bent. So it can follow the clump later or sooner, depending on the value in shape. That means that you can get some random shape into this as well. Right now it's rather much random here. You can't see that we work only with 3 different objects. It feels a lot more. And then twist is how much they should like to go around the parrot. And how many rounds or twistings, so you can see the bending here. Now we're working with objects, so a bit stuck to the topology that we have done here. But if I'm working with pure hair particles, then we get more effect by this twist that I used. So, but still, we can do some changes here, as you could see. And then we have this real random thing here, and that is what is called roughness. So if you use a uniform 0, everything is, let's say, not random so much. We have these things that I get through that we changed, but other than that we don't have any random internally between these, and that is what we can do with the roughness. So if I change the uniform, you can see that something is happening with the grass here. It's moving a bit, but you can't see how much it's moving. That we can change. If I now change the size here and take down the size very much, like I get down like, I don't know, something like this, and then I think we can see it much easier that if I show a uniform, it goes in, we just move the view a bit, and then you can see this again. Okay, now we can see it. When we take uniform up, you can see it's like bending to the right as well as bending to the left. So some are bending to the right, some to the left, as you can see here. Here it's like if I take this up again here, like this, you can see that the part is bending to the left and that part is bending to the right. Size here, the size, the area that should be used for this. So we now have like that part that goes to the left and this part that goes to the right. And I can see that the area is about this size. If I now change the size, I spread out the area and now we have a bigger area that goes to the right and left. So we get another type of pattern as a layer here. Now you can see it's almost like we had a wind blown at this direction. So here is where you control it, so you get some pattern. Working with the size of uniform is more for the complete plane compared to what I showed before, that was more like for each particle. So these methods are working together in the plane to create randomness. Then you can also change the endpoint, the top of the particle, to cause changes in where the strand should end at the top. You can also change the shape here, and depending on how you have put uniform and size, it will react differently. Okay. Another thing that changes the outcome is if you use hair or emitter, as I do here. So if I use emitter, I have a little bit less flexibility, but still you can see the pattern and how it works. Then we have random, so we don't get this even pattern, and that you can change here. And then you get some particles going up, some going to left or right, and it gets even. And then you can decide the size of the random, how much it should affect, and it works the same as it did with the length, meaning that you can decide with a threshold of 0 that everything should be affected of this roughness. However, with a value of 1, well, nothing will be affected of the random and the size. So that is how roughness works, and that, together with the other parameters, give the particles on the plane completely like a random image. So if I now look at it from the camera view, you can see that it's going in all directions. You have different types of length, different types of size. You can't in any way say that we used only 3 objects and 1 flower to get this image. So it's a really powerful way to work with particles, but still maintaining the speed of the computer, even if the physical render will give you a lot of particles. So all this is how it works. And I'm running in cycles, so it will take some time to make a good image. But here you can see that I used only 10 children right now in my viewport, but in the render I get 50 children for each parent. So, and you can put that as high amount of children as you want to when you render, so you have like 1 million of particles to make this really dense image with a lot of grass into this. So that is how children works. Then I will in later sessions go more deep into how I will work with other types of children associated with high particles. But however, now you have a basic understanding on how you can create grass using children particles. So I just say now, see you in the next session, and bye for now.